Alright, let's go ahead and talk about evaluating functions for today. So, when you evaluate functions, you simply just replace x with the value that's in the parentheses here. That's all you're doing. So this really just means to substitute. So, substitute 49 for x. So when we work it out, it should look like this. H 49 equals 50 minus 49 divided by 7. And then you just evaluate. Use your order operations. So we're going to do 49 divided by 7, which is 7. So that makes 50 minus 7. And 50 minus 7 is 43. So, one way you might see the answer is just 43. Another way you can see the answer written is h of 49 equals 43. Also, another way to look at this, you could also write this as an ordered pair. Another way to write this would be x equals 49 when y equals 43. Alright, let's take a look at number 2. Number 2, we're going to substitute, instead of x, we're going to put negative 2. So, substitute negative 2 for x, and then we apply the order operations. So this would look like g of negative 2 equals negative 13 times negative 2 plus 5. Negative times a negative is a positive, so 13 times 2 is 26, and that's going to become 26 times 5. And 26 plus 5, and 26 plus 5 is 31. So, we could write this a few different ways. We could say h of negative 2 is equal to 31. We could also write it as an ordered pair where x equals negative 2 and y equals positive 31. Okay. Let's try another example, number 3. Number 3, we're going to substitute positive 2 for x. So that's basically what that tells you to do. Substitute 2 for x. So let's go ahead and try that one. When we rewrite it, we're going to have k of positive 2 equals 19 times 2 minus 10. 19 times 2 is 38. 38 minus 10 is 28. So we could write that a few different ways. Okay? We could write that as h of positive, not h of, but k of positive 2 equals positive 28, or we could write it as an ordered pair, and we could write when x equals 2, y equals 28. Okay? So, let me go back and change that. That should be g right there, and that first one was h. Alright, let's go ahead and take a look at number 4. Number 4, we're going to substitute negative 5 for x. So we're going to substitute negative 5 for x. So when we work this one out, this is going to say f of negative 5 equals negative 11 plus 20 times negative 5. When we work this out, this is going to be negative 11 plus negative 100, and a negative plus a negative makes an even bigger negative, so this is going to make negative 111. We could circle that, and then we could write our answer in a few different ways. You could see it as f of negative 5 equals negative 111, or you could see it as an ordered pair, a point where x is negative 5 and y is negative 111. Okay. Alright, so far all of our answers, we've had an actual answer. So another way to look at all of these here for 1 through 4 so far, we could also say that when that 49, because there is an answer, because we have an answer here, this could be said to be in the domain. And it's in the domain because we actually got a value here. So all of these can all be said to be in the domain. Okay? Because we actually got a value. It exists. Okay? So in the domain. And the domain means that this x value actually exists. So in the domain. Now, let's take a look at number 5. Okay? Number 5, we're going to substitute negative 7 for x. So let's go ahead and do that. Let's write it out. We're substituting negative 7 for x. Now, let's go ahead. So f of negative 7 equals negative 7 divided by negative 7 plus 7. When we evaluate that, the numerator stays the same, negative 7, and the denominator becomes 0. Now, we should already know that you cannot divide by 0. Dividing by 0 is not allowed in mathematics. So we would write this as undefined. Undefined. Now, because we did not end up with a value, okay, this means that this does not exist. So because this ended as undefined, it's not possible, you're not allowed to have 0 in the denominator, then this is said to be not in the domain. Not in the domain. Okay? So another way we could write this final answer is that there is no solution. We could also say that there is no solution. So this is one way to think about it, that it's not in the domain. Another way is that there is no solution. Okay? Alright. Let's take a look at number 6. For number 6, they're asking us to replace x with negative 7 again. Okay? So, let's go ahead. We know that this means substitute negative 7 for x. And now when we work this one out, we're going to say h of negative 7 equals the square root, it's supposed to be 1, the square root of 7 times negative 7. When we evaluate that, we're going to get the square root of negative 49. Now, right here, whenever you're taking the square root of a negative number, that is something that you're not allowed to do. We can simplify this mathematically speaking. However, technically, there are no, you cannot take the square root of a negative number. Okay? So, this would be said to not exist. Does not exist. Okay, we won't say it's undefined. we'll just say does not exist. So this is what we would also call an imaginary solution. Okay. Imaginary solution. Either way, okay, this is not in the domain. Okay. So because it does not exist, because it's an imaginary solution, it is not in the domain. Alright? And that would be it. And that's only because we can't take the square root of a negative number. Okay, if this wasn't negative, then we could keep going and this would be in the domain. But because it's a negative, you cannot take the square root of a negative number. Alright? Let's take a look at number 7. Number 7, they're asking us to substitute positive 5 for x. So they want us to substitute positive 5 for x. So let's go ahead and take a look at what that looks like. So d of 5 equals the square root of 5 plus 4. When we evaluate that, we're going to end up with the square root of 9, and we know that the square root of 9 is equal to positive 3. Okay? Now, we can, because there is an answer here, we actually get an answer. This means that this is in the domain. Alright? And our solution was 3. So we already know 2 different ways we could write this. One way we could say, d of 5 is equal to positive 3. Or we could say when x is 5, y is 3. Okay? And let's take a look at one last expression for today for evaluating functions. Here, they simply want us to substitute 0 for x. So let's write that out. Substitute 0 for x. Alright? So when we do that, let's take a look. This is going to be e of 0 equals 0 minus 5, and then that answer is squared. Well, 0 minus 5 is negative 5. And when you square negative 5, that's going to be negative 5 times 5. Oh, excuse me. That really means negative 5 times negative 5, which is positive 25. So we get our answer here, which means that this is in the domain. It exists in the domain. Therefore, like I said, does exist. Alright. And we could actually write our solution 2 different ways. Right? We could say that e of 0 equals 25, or we could say when x is 0, y is positive 25. Alright? And that will conclude our lesson for today.